Welcome to my channel Living Linux. I saw a post on Reddit that SpacemiT released a Debian 13 image for the SpacemiT K1 devices, like the MUSE Pi Pro, MuseBook, Banana Pi F3, and seems that they haven't tested the Milk 5 Jupiter and the Litchi Pi 3A, but there's a high probability that it will also work on those devices. So you can download it from the SpacemiT website or from this Google Drive. So yeah, it's not really clear if this is like a really official SpacemiT release, but yeah, they do host it on their website. So yeah, it's at least, let's just say, sanctioned by SpacemiT. And they also applied some patches, like the GPU driver with Vulkan, and that probably is the same one that was released with the Bianbu version 3. And because I also had to do the same tricks to get things working. So let's just say if we are going to try that, I also installed Mango Hut. Where did my notes? There are my notes. So if we do a simple test for Vulkan, then you can see that it has a relatively low CPU load. It's still running at 60 frames per second, so that looks good. Yeah, before I forget, here you can see the system information, Debian 13, Trixie, and yeah, I'm running it on the MUSE Pi Pro, Linux kernel 6.6.63, and we have the GPU driver. So I also ran some benchmarks. So let's say I'll have to skip past this just for the time being. Yeah, so I think this one was the GL Mark II ES2 Wayland. Total score of 373. And I also did the regular GL Mark II for Wayland, and then the score was 235. And yeah, usually I also do the WebGL Aquarium. And that one works with Chromium, doesn't work with Firefox, because they ship it with Firefox ES, which is perhaps more stable, but it also has yeah, might be older features. At least it's not really up to date with the regular Firefox. But here we have WebGL Aquarium, a bit over 30 frames per second with 500 fishes. And if we take that up to 5,000 fishes, then we get around 11-12 frames per second. So, well, I guess for this RISC-V board it's not bad, it's not fantastic either, but yeah, at least we have something to play with. So there's a lot of let's just say buzz around AI on RISC-V, and unfortunately I don't have really fast RISC-V hardware. I don't even have a RISC-V board with an external GPU or a discrete GPU. So we have to do everything on the RISC-V chip itself, and yeah, the current hardware that I have is not that fast, but you can still do some interesting stuff like stable diffusion. The people that have followed my channel for quite some time, they probably have seen this before. So with OnnxStream, developed by Vito Plantamura, you can even run stable diffusion within 512 MB of memory. And here he says that, yeah, regularly you need like several gigabytes of memory to run stable diffusion. I'm not going through the whole installation, but the things that I do want to point out is that you might run into an error. It's also best to follow the instructions here, because especially with this one, he does update to newer versions of X and NPAC, but then he wants to keep it stable at a certain point. So this string might change over time. So yeah, it's best to follow the instructions just from the website. And on RISC-V, there is another thing. Yeah, so ISA string native, that doesn't work. So what you can do is you have to go to the CMakeLists file in OnnxStream source, and then change the architecture from native to RV64 GGUF. And then you can try again, and then it should work. And unfortunately the download, well, for me it doesn't work, but it is possible to download it manually. So you can just click here. So you need to install git LFS. This might fail. Let's just show that. So, oh well, but anyway, I installed it like this. Sudo apt install git LFS. And then you can download the model that you want to use. And then you have to know where you downloaded the model, because then you need to specify that in the model's path parameter. Now this is going to take quite some time, so I'm not going to run it live. As you can see here, almost 21 minutes. And if I go to OnnxStream source build, and here we have the picture that was generated. Well, yeah, the surfboard is not really looking that good, and doesn't look like that the penguin is like really on the surfboard, but well, I guess it's good enough for now. And yeah, you might want to play around with perhaps some of the other models and with more steps. But Stable Diffusion in itself does work. And also that you should not forget to specify RPi. So this is not really specific for the Raspberry Pi, but it's that some chips do not support FP16, and then you have to fall back to FP32. That's perhaps just a lot of technical blah blah, but if it doesn't work, then try to run it with RPi, because then it will use instructions that are supported by, let's just say, older hardware. Although in this case RISC-V is not that old, but yeah, it's still in development. So anyway, that was Stable Diffusion. So next thing is Llama.cpp. So that is a bit like Ollama. So you can use it to run large language models. And let's see. That's not what I was looking for. Yeah, so when I was building Llama.cpp, I got an error message about the curl library missing. So you can either use the switch to turn that off, but I also noticed that and I was too lazy to build it again. But you can install the let's just say development packages for curl, and then it should be possible to install it with curl support. So yeah, if you install this package, then perhaps you can get rid of that error message. So anyway, I did the benchmark with a small large language model, or the small language model, 1.7 billion parameters, quantized. So you can see the PP512, 2.4 tokens per second, and TG128, 2.65 tokens per second. So that's not fast. But again, yeah, we have a modest RISC-V hardware. And hopefully in the future, when we get faster RISC-V hardware, that this will also improve. So let's have a look at that. Let's see. It's in builds, bin. Yep. So if I go back to my notes, did I? No, I didn't write that down, but it's not that complicated anyway. So we want to start Llama command line interface, and then we need to specify the model. So I downloaded the model. Let's say small. let's see. So here we have the system monitor, so we can see if it's going to push the CPU cores. Why is the sky blue? So now you can see that all the CPU cores are doing a lot of work. And this small model, it has a reasonable speed on this hardware. So yeah, so they say that the blue light gets scattered more, and that's why our eyes see more blue light. Well, and of course with a sunset or sunrise, then things are a bit different, but let's just say during the day, that is the explanation. So that was quite an explanation. So I hope you get an impression on the speed with a small language model. Yeah, one other thing that I tried is Box64. So that is a x86 emulator. So I built it from source, and you can find the instructions on the GitHub page. So you can follow the instructions here, but the options, then you need to substitute that with the instructions for RISC-V. And once you've built it and installed it, and I think also the first time, yeah, you also need to execute this command. And then you're not finished yet. And then you need to bundle the x86 libraries. So first you need to install these packages, and then you need to execute this script. And once that is done, you can extract the x86 libraries. And then you can try to start some x86 programs. So this game 2048, it's relatively simple. And let's see, here we are. Yeah, there's one more thing that, let's see. yeah, you probably have to install libfuse 2 T64 to work with app images. And once you've installed that, then you can start a simple x86 Linux program. And I'm not really sure if Wine already works on RISC-V, but yeah, not really interested in that. I mean, like, perhaps at some point in time that I will try to get that working. So yes, you can see that this game is actually working. So box 64 also works. And yeah, since we have Vulkan support, then yeah, I built vkQuake. And let's see, where are we? We're there. So I'm going to use Mango Hut. So I'm running it with the default settings. So let's see if we try to get it full screen. So then it has a hard time to get it at 60 frames per second, but it still looks playable to me. So, and as a last test, I installed Beneath a Steel Sky, and what is that somewhere else? Did I already pass that one? Let's see. So not that one, not that one. Yeah, so you can install it like this, Beneath a Steel Sky. And yeah, interestingly enough, there are also some other similar games like Lure of the Temptress, Flight of the Amazon Queen. So this is going to be my last test for this video. Beneath a Steel Sky. It's a point and click adventure. And it's available from the Debian repository. And it runs on the ScumVM engine.
The old man was trying to tell the future, looking for pictures and he can't find them. Oh, I see. Evil, born beneath the sea. Far from the light of day, I see, growing safe beneath a sky of steel.
So let's skip the intro. And as I said, it's a point and click adventure. So I guess you get the idea, and then with F5 you can get to the menu, and then it's also possible to exit. At least I thought it's possible. Oh, I have to click here. So yeah, it looks to me that let's just say that the performance is similar to Bianbu OS 3, and yeah, we'll have to see if SpacemiT wants to invest some more development time into Debian 13, and well, perhaps that's not really specific to Debian 13, but I think the GPU driver still needs some more work. Well, you could see with vkQuake that it is possible to get some decent performance with it, but unfortunately, let's just say on the OpenGL side, things are not that pretty. So this is all for now, and I hope to see you again in my next video.